In this video, I will continue discussing fire protection systems, and we're going to start looking at, in the previous videos, or the previous lecture, we looked at the fire detection. Now we're going to look at control, indication, and test. So when I was discussing detection, one of the things I did show was test circuitry. And the example I used here was this very simple version, where we have a monitoring circuit, a test circuit, a control unit, but it's very basic. And in older aircraft, that may be all that was there, but in modern aircraft, these systems are more complex. We start to get something where instead of just some relays or switches, in our newer aircraft, we need to link in various computers, the ICAS or ECAM systems, control boards, control cards, or modules. And these systems begin to look like this. And so these are a combination of both digital and analog. So over here on the right, we have our detectors. Now, this specific example is showing detectors that are of the pressure tube type loop detectors, the ones that are filled with helium, and then the center part releases hydrogen to increase pressure. But these detectors can be any number of detectors that we looked at. So it could be the pressure loops, it could be the eutectic salt type loops, it could be a collection of thermal switches that all feed into a control module. So multiple loops, detectors, switches, whatever they might be, are feeding signals into these control modules. And you can see here they show a loop A and a loop B, and that's that redundancy where we typically have two circuits of detectors in a given area in order to make it so that, reduce the chances of a false alarm, but also have redundancy where one can be shut off if it fails and then just operate on a single. In the case of this control module, it demonstrates how it ties into, in this case, like an onboard maintenance computer and ARINC 429 circuitry. And going back to indication from earlier in the semester, ARINC 429 is the bus system that's common on most modern transport aircraft. That's going to feed data into things like the ICAS displays. And so, this part here is taking these signals, turning them into a digital signal, sending it out to things like the onboard maintenance computer, or to identification right here is going to be the ICAS, ECAM systems, where it's going to put messages. In addition to that, though, you can see there's still power going out to analog indications in the forms of things like lights, or it could also potentially be audible indications, which that could be a digital signal or an analog signal. And so this combination is used to provide full indicating capabilities. And that's what we see in a modern aircraft. Now, another item that I talked about earlier, one of the requirements and then kind of function when looking at detectors, is the ability to provide testing. And so the first thing is that these are going to have byte systems. And byte, remember, is an acronym. It stands for built in test equipment. And that's where the B, I, T, and E come in. That makes byte. And at minimum, what we're going to have is a short to ground test, which for this is going to create a indication test. So some kind of indication test. Most of them are a short to ground setup. But there can also be other types, capacitance changes, radarized changes, those kind of things that allow the crew to verify that if there was a fire or overheat or smoke, that it could be indicated. The other part is then the continuity or integrity tests that are used to check system health, and that is to make sure everything is operating how it should be. And so, for instance, it might be making sure that there's continuity end-to-end through a loop sensor. or it might be a certain level of resistance in a resistance or voltage generated in something like a thermocouple-based system. And so that's the other half of the built-in test equipment, the byte. As maintainers, though, there's other functional checks that we may do in order to verify that these systems are operational. So we may actually trigger a true indication rather than a built-in test indication. And so this is, applications here would be using something like a heat gun to heat up a thermal switch or to heat up an indication loop in order to verify that we get an indication of a fire or overheat. Another thing shown here for things like smoke detectors, I'm going to go ahead and delete my wording here that's kind of covering it, but this yellow canister here is a smoke detector test aerosol. So it basically is a little spray can. You spray it and you spray the vapor that comes out of it into a smoke detector, and it will set off the smoke detector. And it is a clear vapor, so it's primarily designed for testing those isotope-based smoke detectors that are able to see clear as well as visible smoke. And there's other maintenance and functional checks that we may do specific to an aircraft or an aircraft type. With all of these systems, then, they send those signals out, and we're going to have various forms of indication, as I talked about above. So, we'll have visible indications or visual indications in the forms of lights, ICAS and ECAM messages, and things like that. In addition, this bottom point here, pull handles, push switches, toggle switches, these are going to provide indication as well. And these are the actual pull handles, push switches, toggle switches that are used to deal with the abnormal situation. And so this is something like a fire handle. So if there's a fire, on a twin engine airplane, typical, this is like a Boeing style, has T-shaped handles. It has one for the left engine and one for the right engine. Then it has a third one for the APU. And so in that case, if you had a number one or left engine fire, the pull handle for the left engine fire suppression system would light up in order to draw your attention to that, while the APU and the right engine would stay dark, so that, to try to avoid somebody accidentally fighting a fire or overheat in the wrong spot. And so that'll light up. And in all these cases, the lights, the ICAS, ECAM message, the pull handles, those are also part of that system that stays on or stays lit up until the point where the fire or whatever the non-normal situation has been dealt with. In addition to that, we'll have typically oral indications in the forms of things like fire bells or klaxons or items like that. And when an indication first takes place, especially something like a fire that's particularly severe, the system is designed to make sure it absolutely gets the crew's attention. And so that often is a sustained oral indication. So it's a fire bell that's constant, or it might be a sustained dynamic lighting, so blinking lights. And both of those things do a great job of getting the attention of the crew, but at the detriment is it makes it really hard to think when you have flashing lights and loud noises. And so the crew can reach up and push either a cancel button or, like what's illustrated here, this is a caution warning push switch that would be on a glare shield. So when you get a warning, the warning portion will light up, a fire warning, for instance, and to stop it from flashing and to turn off that oral, you would reach out and push that button in order to turn it off. But the message would still remain on ICAS. The pull handle would still be lit up. And that way, those will stay in place until the actual fire is put out or the overheat is put out. And then only then will the ICAS message disappear. Only then will the fire handle or push switch, whatever it might be, uh, will will the light will shut off on it. And that's the indication to the crew that they've successfully put that out. The other thing here is a central warning system. A lot of times these are controlled rather than all discrete wiring, especially in digital systems, kind of a separate computer that collects all kinds of warning and cautionary information and is kind of in charge of running things in emergency, and that's almost always powered by DC off of a hot battery bus, so that even if there's a full normal electrical failure, it's able to still provide this indication. One additional item here is this isn't always a warning. This could be cautionary. These same kind of indications could be cautionary or amber messages, and those are usually related to, if we go back up to the bite test, for instance, the built-in test equipment, if we have a failure of a bite test, for instance, these will often warrant a caution message rather than a warning message. So those do a caution message. When we actually do these down here, these are used, these functional checks, we typically are going to get an actual warning message. So it tests both the caution and the warning element of it and tests the integrity of our system. So caution, same thing. If say a fire loop loses end-to-end continuity, or communication is lost to a smoke detector, then you'll get a cautionary message alerting the operators that they no longer have that sensing device to be able to use. So that wraps up the indication and test side of it. In the next video, I will go through various extinguishing systems.